Welcome to the third and final video on fractions, and this will be a continuation on the last video where we spoke about operations and fractions. So the second thing we'll look at is multiplications. Fractions can be multiplied together by multiplying numerators to numerators and denominators to denominators. Also, you can simplify where possible. For example, 3 over 4 multiplied by a half. We multiply the numerators together, so 3 multiplied by 1, all over, we multiply the denominators together, so it's 4 multiplied by 2. This gives 3 over 8. Example 2, 14 over 21 multiplied by 27 over 10. For this one, we multiply 14 by 27 all over 21 multiplied by 10. 14 multiplied by 27 is 378, and 21 multiplied by 10 is 210. Also, we can simplify this. Because we can write 378 as 7 multiplied by 54 and 210 as 7 multiplied by 30, this means we can factor out a 7 out of both the numerator and the denominator. We can also factor out a 6 from both the numerator and the denominator, as 6 goes into 54 9 times and 6 goes into 30 5 times. This means we're left with 9 over 5. This simply means that 378 over 210 and 9 over 5 are equivalent fractions, which we mentioned some videos ago. Another way we could have done this question, let me write back our fractions, is we could have simplified the fractions before multiplying, which would make it a lot easier for us rather than simplifying all these huge numbers, okay? So we already know how to simplify fractions vertically. So we have 14 over 21, we factor out the 7. 7 goes into 14 2 times, and it goes into 21 3 times. So we're left with 2/3 multiplied by 27 over 10. However, we can also simplify diagonally. So 3 into 3 goes 1, and 3 into 27 goes 9 times. This means we're left with 2 over 1 multiplied by 9 over 10. We can factor out a 2 diagonally, since 2 divided by 2 is 1 and 10 divided by 2 is 5. This means our answer is 9 over 5, which is the same thing we got before. Okay, so just an example of why we can simplify diagonally. This is a very simple concept. So let's take the example 2 over 1 multiplied by 9 over 10. Okay, so we know how to simplify vertically. Let's start there. We see that there's nothing to simplify vertically for this fraction nor this fraction. So if we just multiply our numerators by our numerators, 2 multiplied by 9 over denominator times denominator, so 1 multiplied by 10. Now we have one fraction with our numerator as 2 multiplied by 9 and our denominator as 1 multiplied by 10. But again, we can simplify this vertically. Specifically, we can factor out a 2 from our numerator and denominator, as 2 goes into 2 ones and 2 goes into 10 5 times. So 1 multiplied by 9 is 9, and 1 multiplied by 5 is 5. Okay, so let's do the same thing but with diagonal simplification. Since from before we saw that when we multiply out the numerators and the denominators, then 2 will be in the numerator and 10 will be in the denominator, and we'd be able to simplify vertically. This means that we can just simplify diagonally from the jump, because we know where these digits will end up eventually, right? So it will end up in the numerator and the denominator. So let's just factor out 2 from 2, which is 1, and 2 goes into 10 5 times. Now we multiply, since there's nothing left to simplify. We get 9 over 5, which is what we got before. Recall from the previous lecture that in order to find an equivalent fraction when adding or subtracting, with a certain denominator, we have to multiply the numerator and the denominator by a specific integer. Now, here's the rationale behind why. For example, let's take the fraction a half and say we want an equivalent fraction so that the new denominator is 8. From last lecture, we know that we'd multiply the 2 by 4 to get 8, but we'd also have to multiply the numerator by 4 as well to, as I said before, preserve the equivalency of the fraction. This would mean that our equivalent fraction is now 4 over 8. If we take a closer look at this middle part, we see that we're multiplying the fraction a half by the fraction 4 upon 4, right? 4 over 4. But 4 over 4 when simplified is 1 over 1, which means that we're essentially multiplying the fraction a half by 1. And recall that 1 is a multiplicative identity because any number multiplied by 1 is the same number. So when we multiplied a half by 4 over 4, we're essentially multiplying a half by 1. This is the reason why a half and 4 over 8 are essentially the same fractions, which is why we call them equivalent fractions. Example 3. 3 and 1/6 multiplied by 1 and 5 over 7. When multiplying mixed numbers, we write them as improper fractions. So let's convert 3 and 1/6 to an improper fraction. This becomes 3 multiplied by 6 plus 1 all over 6, which is 19 over 6. And 1 and 5 over 7 as an improper fraction is 1 multiplied by 7 plus 5 all over 7, which is 12 over 7. So now that we have our improper fractions, let's multiply 9 over 16 times 12 over 7. We can simplify diagonally as 6 into 6 goes once and 12 divided by 6 is 2. Now let's multiply 19 by 2 all over 1 multiplied by 7, which gives 7 as our denominator and 38 as a numerator. So the last operation we look at is division. When dividing fractions, we find the reciprocal of the divisor, or the second term, then multiply. For example, 5 over 6 divided by 2 over 7. The divisor is 2 over 7, so we have to find its reciprocal, and the reciprocal of 2 over 7 is 7 over 2. Essentially, we just flip the numbers, and if you remember a few lectures back, I mentioned the importance of reciprocals. Anyways, we can now multiply 5 over 6 by our reciprocal, 7 over 2. So our original fraction becomes this. When we multiply, there's nothing to simplify vertically or diagonally. So now we just multiply numerator by numerator. So 5 multiplied by 7 all over 6 multiplied by 2, which gives 35 over 12. Example 2. 1 divided by 4 over 3. Any integer as a fraction is itself over 1. So 1 as a fraction is just 1 over 1. Multiplied by, we take the reciprocal of 4 over 3, which is 3 over 4. Now we can multiply 1 multiplied by 3 all over 1 multiplied by 4. Our answer is 3 over 4. Example 3. 18 over 11 divided by 27 over 22. So we have 18 over 11 multiplied by the reciprocal of 27 over 22, which is 22 over 27. There is nothing to simplify vertically, but we can simplify diagonally. 11 divided by 11 is 1, and 11 goes into 22 twice. So now we multiply our numerators together, 18 multiplied by 2, all over our denominators, which is 1 multiplied by 27. We can factor a 9 from the numerator, as 9 into 18 goes twice, and we can also factor 9 from the denominator. 27 divided by 9 is 3. So we're left with 2 multiplied by 2 all over 1 multiplied by 3. We get 4 over 3 as our answer. Last example. 6.5 divided by 2 and 3/5. So like with multiplication, we have to write our mixed numbers as improper fractions. So 6.5 as an improper fraction is 13 over 2, and 2 and 3 over 5 as an improper fraction is 13 over 5. Now we can divide. 13 over 2 divided by 13 over 5. This is 13 over 2 multiplied by the reciprocal, which is 5 over 13. We can cancel at 13 diagonally, leaving us with 1 multiplied by 5 all over 2 multiplied by 1. This is 5 over 2. Okay, so this brings me to the end of our videos on fractions. We basically covered all the fundamentals that I wanted to go over. If you have any questions, remember to send us an email linked in the description below. Well, the website is linked in the description below. You can email us anytime you want. And remember to like and subscribe to this channel. We've covered a lot so far, so remember to just keep refreshing your memory as it pertains to things like LCMs, prime numbers, multiples, factors. It's really important leading up to completing the rest of the videos. Yeah, and that's it for this video. We'll see you in the next one.